afternoon all. I am S. Vijayalakshmi working as an assistant professor at the SNS College of Technology. Now our third year CSC students are going to discuss about code optimization techniques in automata theory and compiler design.
Yeah, code optimization is a crucial compare optimization technique that improve execution speed and then the efficiency of a program by transforming loops, which are often the most frequently executed part of your program. Since a loop execute multiple times, so even a small improvement inside the loop can yield a large overall performance gain. So the objective of loop optimization are reduce loop overhead and then decrease the number of executed instructions and then improve instruction level parallelisms and then reduce memory access time at last enhance local of reference. So there are some common loop optimization techniques. The first is the loop invariant code motion, which is a move computation that yields the same result in every iteration outside the loop. So the reason is such expressions do not depend on the loop variable and hence need not to be recomputed every time. And then the string reduction, second one. The string reduction, which is replaces expensive operations like multiplications and then divisions with the cheaper one like addition, subtraction, etc.
So there are so much eliminations. It an expression is computed more than one and its value does not change in between. Compute it only once and reuse the result. Its goal is avoid redundant computations and improves execution time. Constant folding, evaluating constant expressions at compile time instead of runtime. Its goal is reduce unnecessary runtime operations. Constant propagations, if a variable is assigned a constant value, replace further uses of its with that constant wherever possible. Its goal or reduce memory lookups and enable further optimization like constant folding.
So we have seen lot of automation technique like machine independent. These are the machine independent optimization and loop optimization techniques. And there was also so much of loop optimization techniques which has been used to minimize the code and optimize the code generation. For example, dead code elimination. So dead code elimination means we will remove the line which is never used in the code. For example, they have given a very big code, and if any variable is not used in anywhere, we can just remove that code, because even though if it is in the code, if it is not in the code, there is no change. We will get the same output in the program. And another one is using algebraic expressions. So in programs we might use like algebraic expression like x is equal to x star 1, y is equal to y star 0, or y is equal to y plus 0. So whatever we do here, we will get the same input. Whatever the input is, we'll get the same as the output. So instead of multiplying using a algebraic expression like 1 and 0 for addition and multiplication, we can directly use these variables as an input as well as also an output. So this is also reduce the code reduce the code which is always multiplying each and every time. And also in looping also we can use code optimization technique. Instead of using many expensive expressions like multiplication, division, we can go for a cheaper ones like addition and subtraction, because this will not take so much of time of CPU usage. It will reduce CPU usage, and then we can store these variables in the register and memory efficiently.
Advantages of loop optimization: improve execution speed, reduces the number of operations executed inside loops. Of loop optimizations: improve execution speed, reduce the number of operation executed inside loops, better CPU utilization, efficient use of registers and reduced pipeline styles, reduced runtime overhead, cuts down overhead from loop control, improves cache performance, techniques like loop tiling, interchange, and enhance locality of the reference, minimizes expensive operations, length reductions replace costly arithmetic operations like multiplications with faster ones, reduce memory access, frequently used values are kept in registers rather than memory, leads to further optimizations, enables data code eliminations, common sub-expression eliminations, etc.
So finally, loop optimization technique is the best technique used in the code optimization because this loop optimization technique means it improves the performance by loop, reducing the number of instructions that has been executed inside the program and overhead of the loop itself. And since the loop has run many times, even a small improvement in the loop can cause a huge impact in the program. So which is very helpful in code optimization technique. And the main goal of this loop optimization is nothing but to reduce the repeated computations and to minimize the memory access inside the loop and decrease the loop control overhead and finally increase instruction level parallelism.